First off, the basics. The absolute basics are distance is equal to speed into time, and this is something I'm pretty sure that you are hearing for the first time, right? So distance is equal to speed into time. Now, if you think about it, if let's say time is a constant, then distance is proportional to speed. When speed is a constant, then distance is proportional to time. And when distance is a constant, then speed is inversely proportional to time, right? So let me show you an application of this very simple thing. And many a times you will get questions in CAT also basis this very simple fact. Let's see a question. Two trains start simultaneously, one from Bombay to Kolkata and other from Kolkata to Bombay. Now they meet each other at Nagpur, which is at a distance of 700 kilometers from Bombay. So meeting at Nagpur, this is 700. So this remaining must be 900 because the total distance has been given as 1600. Now what's the ratio of the speeds? Now what is happening here? What is happening here? This point, which is Nagpur, they are meeting at the same time. So the time the first train travels from B to N, the second train travels from K to N. So since the time is a constant, distance must be proportional to speed. So therefore, what will be the ratio of the speeds? Same as the ratio of distances. So ratio of the speeds will be 7:9. I hope this is clear to you. Very simple thing, but very important. Let's move forward. Important aspect in TSD is application of harmonic mean. There are a couple of cases where you will apply harmonic mean and it works as a shortcut. Let us see the first case. Whenever you have distance as constant, let's say person goes from A to B, let's say the speed that he goes is 60 and speed that he comes back is 40. In the first case, home to office 40 km per hour and office to home at 60 km per hour, right? The excitement of coming back home, hence greater speed. Now, what is the average speed here? All you have to do is take harmonic mean of the two. So whenever distance is a constant and you want to calculate average speed, a lot of people, the mistakes that they make is they have to calculate average, they do 40 plus 60 by 2 and get 50. That's absolutely incorrect. So what do you have to do? Here you will have to take a harmonic mean. So 40 and 60. How do you take the harmonic mean of two units? So harmonic mean of 2 units is 2 upon 1 by A plus 1 by B. If you simplify, this becomes 2AB upon A plus B. So you just apply it here, 2 into 40 into 60 upon 40 plus 60. So this becomes 100. And if you will divide it, so this becomes 4 into 6. So let's take it 100. So this 0, 0, 0. So 4 into 6, 24 into 2 is 48. Therefore, the average speed in this case is 48 and not 50. That's the first scenario. Second scenario wherein you can use harmonic mean will be whenever time is in arithmetic mean, speed is in harmonic mean, and vice versa. So let's say if the distance is a constant, so then we know that speed is inversely proportional to time, or time is inversely proportional to speed. So if let's say time is in arithmetic mean or arithmetic progression, right, then speed is in harmonic progression, and vice versa. If speed is in arithmetic progression, then time is in harmonic progression. Let's understand this concept and let's apply this. If I travel at 10 km per hour, I reach office at 10:30. If I travel at 15 km per hour, I reach office at 10 am. At what speed should I travel so that I reach office at 10:15? Very simple. You see the time here, 10, 10:15 and 10:30. The time is in AP, right? In the first case, let's say you are taking X minutes. Second case, you are taking X plus 15. Third case, you are taking X plus 30. This is in AP. Therefore, since the time is in AP and you are taking the same route, meaning distance is a constant, then the speed must be in harmonic mean. So for 10:15, all I have to do is take harmonic mean of 10 and 15. That will become 2 into 10 into 15 upon 25. So 2 times, 5 times, 3 times. So 4 into 3 is 12 km per hour. As simple as that. How simple is this question? if you understand this basic concept. Let's apply it in one of the CAT questions. Arun, Barun, Kiran start from the same place and travel in the same direction at speeds of 30, 40 and 60. Barun starts 2 hours after Arun. So let's say Arun takes T hours. Then Barun takes T plus 2 hours. Sorry, T minus 2 because starts 2 hours after. So T minus 2 hours. If Barun and Kiran Mala overtake Arun at the same instant, then how many hours after Arun did Kiran Mala start? Very simple question. Let's see here 30, 40 and 60. 30, 40, 60. What do you note here? 30, 40, 60. So if you see 2 into 30 into 60 divided by 90, 3 times, and you have 20 times, so 40. So 40 is the harmonic mean of 30 and 60. So here if you will see, speeds are in harmonic mean, which means that the time taken must be in arithmetic mean. So if let's say Arun takes T hours, Barun takes T minus 2, then Kiran Mala must take T minus 4 for this to become an AP. So after how many hours did Kiran Mala start? 4 hours. I hope this is clear to you. So brilliant CAT question solved with such ease. I hope you enjoyed it. Let's move forward and see a few more applications. Another important aspect is product constancy. It is very, very important. So just revise it here and solve a few questions. What does product constancy say? Whenever you have two variables multiplied to give a constant, if one of the variable increases by 1 by x, the other reduces by 1 by x plus 1. And if one variable reduces by 1 by x, the other increases by 1 by x minus 1. Let us see an application of this. A boy walks at 1/3 of his usual speed. So has reduced his speed by 2/3. We can write it that he has reduced his speed by 1 upon 3 by 2. Right? Therefore, he must increase the time taken by 1 upon 3 by 2 minus 1 using this. 1 by x reduction, 1 by x minus 1 increase. Remember, distance is a constant here. Right? So whenever speed into time is equal to distance and distance is a constant, you can apply product constancy. So 1 by 3 by 2 minus 1 becomes 1 upon 1 by 2 becomes 2 times. So originally, let's say, the time taken in this case, wherein he was getting 20 minutes late. Or originally, let's say the time taken was t minutes. So it has increased by 2t. So 2t is equal to 20 minutes. So therefore t is equal to 10 minutes. So originally he used to take 10 minutes, and after reducing his speed, he used to take 30 minutes. Very simple. Now this is product constancy. Let's apply it in one more example. If a man walks at a rate of 30 km per hour, misses a train by 10 minutes. However, if he walks at the rate of 40 km per hour, he reaches the station 5 minutes before the departure. Okay. Now what's happening here? From 30 to 40. Distance is a constant, right? Distance to the station is a constant. So 30 to 40 increases his speed by 10. So what's the ratio? 1/3. Increases the speed by 1/3. So here I will use this one. One of the variable increases by 1 by x. The other must reduce by 1 by 3 plus 1, which is 1 by 4. So the time must reduce by 1 by 4. So originally in the first case where he was missing the train by 10 minutes, let's say the time taken was t. So t, it reduces by 1/4. So t by 4. And what is the difference? First case late by 10 minutes. Next case early by 5 minutes. The difference is 15. So t is equal to 60 minutes. So originally at 30 kilometers per hour, he was taking 60 minutes. So what is the distance? 30 kilometers, because 60 minutes is same as 1 hour. I hope this is clear to you. Brilliant question, brilliant application. Might find a few questions in CAT and other MBA entrance exams as well. Let's see the next question here. Talking about relative speed, which is again a very important concept. What does relative speed say? Put very, very simply, if I have two objects here, let's say first object here and second object here. First object moving in this direction A, second object moving in this direction B. If the first object has to catch the second object, in that case, then the time taken will be, let's say, the distance d upon A minus B. Difference of the speeds in case the objects are moving in the same direction. You can get into the detail of this where you can say that the first object with reference to the second object starts moving at a minus b and second object comes at rest, right? So that's the concept of relative speed. Now, if the objects are moving in opposite directions or towards each other, then the time taken will become distance upon a plus b. That's as simple as that. Let's try and apply this so that we understand this clearly. So in this case, there is EMU, Meerut, Hapur, Ghaziabad EMU start at the same time from Ghaziabad and Meerut and proceed towards each other at 16 and 21. When they meet, it is found that one train has traveled 60 km more than the other. The distance between the two stations is what? Very simple, very, very interesting question. Let's see what happens. Now, when they will meet, whenever they will meet, time is always a constant. Right? Whenever they will meet, time is always a constant. So in this case, time is a constant. Therefore, distance traveled must be proportional to the speed. So one train has traveled x plus 60, the other has traveled x, and the speeds are in the ratio 21 and 16. So if you will just solve this, this becomes 21x, 16x plus 16 into 60, 5x is equal to 16 into 60. So this becomes 16 into 12. So this becomes 192. X plus 60 becomes 252. Just added 4, 4, 4. So the answer to this question is 444. Let us understand a few important things here which will help you further in CAT exam. So there is one more scenario wherein, let's say for example, there are points A and B. A person moving at speed x moves from this direction and person moving at speed y moves from this direction. Let's say they meet at a point C here. After meeting at the point C, let's say this person X or the person traveling at X takes Tx time to reach B, and the person traveling at Y after meeting and reaching the point C travels the remaining distance at the speed at taking time Ty. In this case, what will happen? Let's see. Initially, when they meet at C, let us say that they take time t. So therefore, the distance AC will become x into t and the distance BC will become y into t. Now what will happen? This person, the first person traveling from A, will cover the distance yt in tx time. Right? So covering the distance yt with his speed x. So y into t divided upon x, that is taking tx, and the second person who's traveling at speed y will travel xt at his own speed and will take ty time, right? So if you will just divide it, you will realize y square upon x square is equal to root over tx upon ty. You can use this. So y square upon x square is tx upon ty, so y upon x is root over tx upon ty. An important formula you can use. There has been several questions on this concept also in CAD. So just remember this, practice a few questions along this line also. Okay. And if you have to calculate distance also, you can calculate, because now you know the speeds as well. Moving forward, let us see. A thief escapes from a prison at 2 p.m. and travels away at a speed of 30 km per hour. The police realize the escape at 3:30 p.m. and chase at a speed of 40. Now this is a perfect relative speed problem. So at 2 p.m. he moves and he travels at a speed of 30 km per hour till 3:30, right? Till 3:30 there is no chase. So 1.5 hours here, 1.5 hours here multiplied with 30. So he has already taken a lead of 45 kilometers. So the thief has taken a lead of 45 kilometers and police starts at 3:30. Now the police chases at a speed of 40 and he runs at a speed of 30. Right? So what will be the time taken? The time taken will be 45 upon 40 minus 30, moving in the same direction, so 10. Therefore time taken will be 4.5 hours. From 3:30, if you will adjust 4.5 hours, you will be able to catch the thief at 8 p.m. I hope this is clear to you. Brilliant. Relative speed is also clear. Moving to another concept, very, very important, circular races. There are two cases here. Okay, first case is meeting for the first time on the track. Second case, meeting for the first time at the starting point. Right? So two very, very important cases. Let's say in the first case, here you will see 1200 meters. Okay, so the track length of 1200 meters and the speeds are 27 kilometer per hour, 45 kilometer per hour. I am sure you all know the conversion from kilometer per hour to meter per second. Kilometer 1000 meters and hour 3600 seconds. So if you'll just solve this, becomes 5 upon 18. So if you multiply with 5 upon 18, you will get conversion to meter per second. So this will become 5 upon 18 if you do. This becomes 7.5 meter per second. 45 if you do 5 times and 2 times 2.5. So 12.5 meter per second. So this is 12.5. This is 7.5. Right? Now when will they meet again for the first time on the track when they start running in the same direction, in the opposite direction? Think about it. Let's say they are moving in the opposite direction. One person moving in this direction, one person moving in this direction. Speeds A and B. It is as good as a linear track, isn't it? Two people moving from opposite ends, moving in, with speeds A and B. The time taken will be as good as, in a linear scenario. So 1200, since moving in opposite directions or towards each other, the speeds will add up 12.5 and 7.5, so 20. So 60, when they are moving in the opposite direction, then 60 is the answer. 60 seconds it will take. Now let's take another case when they are moving the same direction. When they are moving the same direction, it will be, again, what you'll have to do is similarly, like you've done in the second case, first case, T upon A minus B. So that becomes 1200 upon 12.5 minus 7.5, that is 5, so 240. So when you have to find out when they meet on the track, there is no hassle. You can solve it as you have solved in linear cases, right? In linear race like this, we have solved. Similarly, you can solve when you have to find out when they meet on the track. Second kind of question is when they meet at the starting point. That's very, very interesting. So let's say in the second case, there is a track of 60 kilometers and there are two people starting from the same point, moving at 20 and 30. Now in this case, think about it. Let's say the first person moving at 20 kilometers per hour will cover the track and come to the starting point in 3 hours, then in 6 hours, then in 9 hours, then in 12 hours, so on and so forth. The second person traveling at 30 kilometers per hour will come to the starting point in 2 hours, 4 hours, 6 hours, 8 hours, 10 hours, and so on and so forth. Now if you think about it, when do they come at the starting point and meet up? Will be nothing but the LCM of 3 and 2, which is 6. See, that's the common time, right? So what's the answer here? In this case, the answer is LCM of length upon speed of A, length upon speed of B, irrespective of same direction or opposite direction. It will take the same time to meet at the starting point, right? So in this case, what will be the time? 6 hours. Now if you want to calculate when do they meet next, you have to take the multiples only, right? So if you see when are they meeting next? 12, which is the multiple of the LCM, so 6 into 2. Next will be 6 into 3, 6 into 4, right? Going on, so on and so forth. I hope this is clear to you. Brilliant. I am pretty sure you all know how to calculate LCM of fractions. So you have LCM of, let's say, A upon B, C upon D. You have to take LCM of numerators and HCF of denominators. And this is vice versa in the case of HCF. So if you have to take HCF of fractions, A upon B, C upon D, then you have to take HCF of numerator and LCM of denominators. I hope this is clear in a holistic manner. Let's move forward and see the last but not the least, boats and streams. Very simple topic. Let's say what happens in boats and streams. So let's say you have a river. The river has a certain stream, certain current speed. So let's say the speed of the current is y. Let's say your boat is also moving in the speed here, and the speed of the boat in still water is x. Then the stream is going to support the boat, right? And the boat effectively starts moving at a greater speed, which is x plus y. And similarly, if the boat is moving in opposite direction, the speed will become x minus y. The former case is called downstream. The latter case is called moving upstream. So upstream is moving opposite to the current, downstream is moving towards the current. And beyond this, it is only application of linear equations in one or two variables. So let's see what would be the speed of a boat in still water if it covers a distance of 40 kilometers in 4 hours in upstream. So let's say the speed of boat in the still water is x and the speed of the current, let's say, is y, right? In that case, 40 upon upstream, so x minus y is equal to 4 hours. Covers 40 kilometers in downstream in 2 hours. So 40 upon x plus y is equal to 2. So this becomes 20. X plus y is equal to 20 in this case. X minus y is equal to 10 in this case. So clearly x is equal to 15, y is equal to 5. So what's the speed of the boat in still water? That is 15 kilometers per hour. I hope this is clear to you. I hope this is all right. Thank you so much guys for joining in. In the next part, we will solve time, speed, distance, actual CAT questions. We've solved a few good questions here, but we'll take up a few more really important and relevant questions from last 5 to 6 years of CAT. God bless you all. Take care and bye-bye.